Hey there, kiddos. In this video, we're going to go through how to solve the area of a rectangle. We're going to solve area problems with a rectangle or involving rectangles. So let's take a look at our Think About It question, which says that Mr. Boyer is creating a rectangular garden outside of his house that has an area of 18 square units. So you want to make sure that we annotate that. 18 square units means that we have 2 units. Or since it's square, that would be to the second power. To the second power means that we're going to have two units that are going to be multiplied to each other. It says, using the grid below, draw all the possible gardens that he could create with whole number dimensions, and then fill out the table for each of the following that you drew. So how do we find the area of a rectangle? Well, to find the area of a rectangle, please go ahead and write this in your composition notebooks. We're going to be multiplying the length times the width. And you'll see that for the letter L, I'm going to use the cursive letter L so that we don't mistake that to be like the number 1. So we're multiplying length times width. So if we want the area to be 18, well, the easiest dimension there would be 1 by 18, because 1 times 18 gives us 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we would look at this, and this would give us a 1 by 18. That's one possible shape for Mr. Boya's rectangular garden. Is that the only one? No, we could also multiply 2 times 9, or 2 by 9 would also give us 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then double that up. 5, 6, 7, 8, 9. And so we have a 2 by 9 rectangular garden. Is that the only one? Is that the last one? No, there's another one that we could do. We could do 3 times 6 would also give us 18. So the dimensions of this square or this rectangular garden would be 1, 2, 3, 4, 5, 6. And then we would have that 3 by 6 will give us 18. So to find the area, it's length times width. Now, here we see that we're being asked to find also the perimeter. What is perimeter? Please write this in your composition notebooks as well. That perimeter is adding all the sides of our figure. So if we add all the sides of a figure, that's going to give us our perimeter. So we would add all the sides when we're finding the perimeter. So when we look at our first rectangular garden, it's 18 would be the length here. This would be 1, and then this side would also be 18. So we have 18 plus 1, 18 plus 1, and that would give us a total of 38 units. What about the second one? We have 9 by 2, so we have 9, 2, 9, and 2. This would give us 36, because 9 plus 2 and 9 plus 2 gives us a sum of 36. And then what about the last one? This one right here, we have 6, 3, 6, 3. This would give us a perimeter of also 18. Great. The last question says, Mr. Boyer believes that no matter which garden he chooses, the perimeter will be the same. Do we agree or disagree? We should be disagreeing, because as we can see with what we've done, the actual work, that the perimeter changes when the dimensions of the rectangular garden changes as well. When it was 1 by 18, we saw that the perimeter was 38. When it was 2 by 9, we saw that the perimeter was 36. And when it was 3 by 6, we saw that the perimeter was 18. So we do not agree with Mr. Boyer. Our perimeter will change if the dimensions of the rectangular garden change as well. Let's take a look now at our test the conjecture. Test the conjecture says that the area of a rectangle is 7 square meters. The length and width of the rectangle are unknown. What set of possible whole number dimensions yield the shortest perimeter? All right, so area of a rectangle. We know that area is what? Area is equal to length times width. So we've annotated We now have our model, which is actually drawn out the rectangle. The only values that we can multiply that will give us 7 is 1 times 7. So we'll add 1, 7, 1, 7. So 1 times 7, length times width gives us 7. What's the set of possible, the shortest perimeter? Well, 1 plus 7 is 8. 1 plus 7 is 8. So 8 plus 8 would give us 16. So for the area is equal to 7 square meters, whereas the perimeter would be equal to 16 meters. So you'll notice when we're squaring the meters, we can write it as square meters, just the word, or meters to the second power, which means the same thing as this. What about test of conjecture number 2? Test of conjecture number 2 says the area of a rectangle is 48 square meters. So 48. The length and the width of the rectangle are unknown. So let's go ahead and draw our rectangle. What set of possible whole number dimensions yield the largest perimeter? So to multiply to get 48 is 1 times 48. That's not it. You could have 2 times 24, but that's not it. You could have 3 times 16, but that's not it. You could have 4 times 12. That's not it. You could have 6 times 8. Each of these would give you a area of 48. All right. What's the largest possible perimeter? Well, if we go back to our think about it question, we recognize that the largest perimeter usually is going to be whatever you are multiplying times 1. But let's go ahead and check to see if that's true. Perimeter would be you add all the sides. So if we had 48 and then 1, 1, that would be 48 plus 1 is 49, and then 48 plus 1 is 49. So 49 times 2 will give us 98. Here, if we had 24 plus 2 and then 24 plus 2 again, that would give us 26 times 2. 26 times 2 would give us 52. If we have here 3 plus 16 is 19, and then 19 times 2, that gives us 38. So already, if you're noticing, as we go down, 4 times 12, that'd be 4 plus 12, which we have a 16. 16 times 2 is 32. 6 plus 8 is equal to 14, and then 14 times 2 is equal to 28. So the largest perimeter would be 98, which corresponds to our dimensions of 1 to 48. Now let's take a look at our partner practice.